so I'm going to talk about a project that we are currently working on and is about to finish. This is my group at Napier, and the work I'm going to present is mostly from the two first people in the photo. Okay, so the project is called CIVIL, standing for Common Sense and Visually Enhanced Generation. So the overall idea is, so essentially we work on dialogue and natural language generation. So the idea is that we wanted to create a dialogue system that takes as an input a document with instructions. You can think about like a cooking recipe or like building IKEA furniture, etc. Passing this as an input to a dialogue system and then let it have a conversation with a human to help the person to do whatever the task is to do. So while starting working on that, we realized we have to solve first some challenges. Firstly, it was very obvious that when people want to perform a task, many times the task has to be split into subtasks, or sometimes you have to abandon the original task and do something else. For instance, when you cook a recipe, you might realize, oh, I don't have olive oil. So then the task is to find a substitute. So being able to actually capture this knowledge and put it into the dialogue system in order to be able to have the same behavior was quite difficult. So the way we went about that was using external knowledge bases to actually complement the original source data. The second challenge that we faced was that not all the knowledge that was mentioned in the original the original document was explicitly mentioned. So there are a lot of things that they're implied in the documents. We expect people to have some basic level of doing things. And that's one of the things that actually a neural model cannot really understand how to do. And then we had the third challenge, which expands a little bit of the implicit knowledge, but it's a little bit wider. We call it common sense knowledge. Yeah, we can have arguments about what is common sense knowledge, but that's fine. Let's now agree that we named common sense things that people know, and we expect other people to know. For instance, that you can substitute butter with olive oil, or that there is one way to like chop onions or whatever. So there are, we split common sense knowledge to different things. So there are things about space, like specific objects can be in specific positions. Things have to, time is important. Like you do the steps in a recipe in order, like you can't just start from the last step and then move to the first. And other things that we need to take into account, like object properties, like the context and so on. So that was the last challenge that we wanted to, that we needed to address. And what we did, we designed this system that we call Taskmaster. And the idea was that we actually used both a neural model and rule-based systems, a rule-based system together, like a hybrid model, in order to solve all of these challenges together. So just to put things into context, most things you see, like ChatGPT, since you all know it now, it's completely neural-based. And then you also have rule-based systems like Alexa, which is more rule-based rather than neural-based. So what we did is build something much less powerful, of course, by merging these two different technologies. So the idea of the dialogue system is that it starts by giving people the instructions step by step, but then when the human user wants to ask something different or needs to complete another task, then the system moves into a neural model that works as question answering, like able to like the way you'd like Google something while you're doing something. So this is the type of thing we wanted to implement. So we observed that by merging all these different technologies, we managed to help the dialogue system like express this implicit knowledge more explicitly. It was more able to pretend that it understands the context, because obviously it doesn't. And it showed that it's more like flexible in managing the whole dialogue. And I'll try to play this video to show you some examples of what it does.
Introducing Euclid, a humanoid robot with a unique AI system. We combined rule-based and generative models to create Taskmaster, a spoken dialogue system for task-based human-robot interaction. In our research, we focus on the cooking domain and explore the following 5 case studies. Confirmation questions.
How many onions do I need?
1.
Flexible question answering.
What can I use to roll the dough?
A rolling pin.
Relevant domain knowledge.
What do chopsticks look like?
Slender plastic or wooden sticks.
Clarification questions.
Do I need butter for the first part of the recipe?
They do not call for butter.
Unplanned occurrences.
Euclid, the sauce is sticking in the pan.
Continue to stir occasionally.
Okay, so we did a human evaluation of our system, not with a robot, but with a chatbot. And we asked people to compare it to like a rule-based, we actually gave them a rule-based alternative and asked them like, is it more like natural? Does it understand the questions and all of these things? So yeah, we found out that our system is well, very flexible. I was able to like resume conversations when it had to change the communication goal and all this. So yeah, I haven't put the exact results there because I'm sure most people don't really care. So what we do next is we actually want the robot to act as the personal assistant. So our current system also has a vision system that checks what the person is doing. With many problems, but yeah. And our next plan is to run a human evaluation with a robot, and hopefully with an NHS group that does occupational health therapy. But we'll see if we'll have time to do that. So that's all from me. Thank you.